Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Ardian Daniswara. Di video ini saya akan mempresentasikan tugas besar metode numerik yang berisi mengenai kuis dan juga tambahan dua contoh soal pada pertanyaan yang nomor 2. Kita mulai dari pertanyaan yang pertama. Uh, Elaborate your understanding of conscious thinking using the DE5 concept. Jadi yang pertama yaitu intention. This is understand how conscious thinking can be applied using the DI5 concept. And the initial thinking is conscious thinking involves being fully aware and deliberate about thinking processes, decision making, and actions taken. This means every step in the problem solving process should be done with full attention and mindfulness, considering every factor that might affect the outcome. So about the idealization, begin by gathering all relevant information and identifying the key elements of the problem. And then the instruction set, conscious thinking would lead to a more efficient and effective problem-solving process. This involves not just understanding the problem at hand, but also recognizing the broader context, identifying underlying assumptions, and being open to revising one's approach based on new information. The DA5 method provides a structured and approach to achieving this ideal by breaking down the process into manageable steps. And then we can continue to the second question. Consider a problem in engineering that is required to solve using a numerical method. Use the A5 to deal or solve this problem. So we can start by the first problem. So the first problem is how to measure the fluid mechanics problem. So the intention, solve a fluid mechanics problem using a numerical method. And the initial thinking, solve fluid flow through a pipe using a numerical method such as finite element method. Idealization is the ideal solution would be an accurate simulation of fluid flow with velocity and pressure profiles validated by experimental results. We can continue the instruction set. Clearly define the engineering problem, including parameters such as pipe geometry, fluid properties, and flow conditions. Break down the problem into smaller, manageable parts, then identify boundary conditions, initial conditions, and relevant physical flows. Imagine an ideal computational model that perfectly replicates the physical phenomenon without numerical errors. Develop a numerical method using FEM software such as ANSYS and GFDsoft. Set up the mesh, boundary conditions, and initial conditions. And then we can run the simulation and refine the mesh if necessary. So we step to the next problem. It's about a heat distribution in metal plate. The intention is the goal to understand and predict the temperature distribution across a metal plate subjected to different heat sources and boundary conditions. This information is crucial for applications in thermal management and materials engineering. Initial thinking. The metal plate is heated at certain points, while other edges are kept at a constant temperature. Understanding how heat distributes over time can help in optimizing cooling strategies in electronic components or manufacturing process. Idealization. Imagine an ideal scenario where We have a perfect model that can predict the temperature at any point in the plate with high accuracy and in real time. This model would consider all physical properties and boundary conditions perfectly, providing insights that can be directly used to improve thermal designs. We can step to the next instruction set. First, define the geometry and mass, and then set initial and boundary conditions, and then discretize the heat equation, and then develop the numerical algorithm. And we can run the simulations. So we continue to the last problem. It's about the structural deformation of a beam under load. So the intention is to analyze and predict the deformation and stress distribution in a beam subjected to various loads. This analysis is crucial for ensuring structural integrity and safety in civil and mechanical engineering applications. About the initial thinking is to determine how a beam deforms under a specific load. Understanding the stress distribution and deformation can help in designing safer and more efficient structures. The idealization is an ideal scenario. The numerical model would accurately predict the deformation and stress distribution with high precision. This model would consider all physical properties and loading conditions perfectly, providing insights that can be directly used to optimize structural designs. The instruction set: create a finite element mesh representing the beam. The finer the mesh, the more accurate the results. But this also increases computational cost. And then we define the material properties of the beam, such as Young modulus and Poisson ratio. Then we implement the FEM algorithm in a programming language like Python or MATLAB. Solve the system of equations obtained from the stiffness matrix to find the nodal displacements. Then we run the simulations. We continue to the third question. If there is value added to of a DA5 use in your learning process, experiential learning, then explain it. So I will explain this in day 5. So the first is intention. The intention here is to articulate the additional values that the DE5 method brings to the learning process, particularly through experimental learning. The initial thinking. Experiential learning is a process through which students develop knowledge, skills, and values from direct experiences. This hands-on process is crucial in fields such as engineering, where practical application of theoretical concepts is essential. The DA5 method, with its structured approach, enhances this learning process by providing a clear framework for problem solving and continuous improvement. Utilization. In an ideal learning environment, the DA5 transforms students from passive recipients of information to active problem solvers. They would not only grasp theoretical concepts but also apply them effectively in real-world scenarios, developing a deeper understanding and retaining knowledge longer. And the instruction set. AI5 provides a structured approach to problem solving, which helps in breaking down complex problems into manageable parts. This framework ensures that students approach problems methodically rather than haphazardly. The A5 encourages conscious thinking, where students critically analyze each step of the problem-solving process. This develops their ability to think deeply and critically about the problem they encounter. So we continue to the last question. Do self-evaluation and write it down. Intention. The purpose of this self-evaluation is to reflect on my learning journey, assess my progress, and identify areas for improvement. Initial thinking. Self-evaluation is a critical component of the learning process. It allows me to acknowledge my strengths and weaknesses, celebrate achievements, and recognize areas where I can improve. This practice not only enhances my academic performance but also contributes to my personal and professional development. Utilization. In an ideal scenario, my self-evaluation process would be thorough, honest, and constructive. It would provide clear insights into my progress and offer actionable steps for improvement. This process would ultimately lead to continuous learning and growth. So, the self-evaluation, it documents what I've learned from this process. Determine if I met my initial goals, identify strengths and areas for improvement, and then develop a plan for how to improve in future projects, incorporating lessons learned. I think that's for my presentation in this video. I would like to say thank you for watching my videos and see you next time. Wassalamualaikum warahmatullahi wabarakatuh.